So the energy security crisis in Europe was already a problem even before the war in Ukraine. Of course, the war made it worse, especially for countries who were heavily dependent on Russia for this energy. So in less than 2 years, European countries were forced to shake things up and diversify their energy assemblies or their fuel assemblies. So this also meant that they are now gearing up to build new nuclear reactors using Western tech. This is a step in the right direction when it comes to energy security worldwide. There's a lot of room for improvement, of course, when it comes to ensuring the security of supply and advanced reactors in the midst of geopolitical conflicts. I can't wait to hear more about this in the next session. And just so you know, there will be a Q&A with the audience. So do start thinking about those tough questions so that you can ask them right to the speakers. It is my pleasure to welcome our next panel moderator, Cécile Maisonneuve, President of Decisive. She will take over from here.
Thank you. Good afternoon, ladies and gentlemen. Thank you for joining us on what you have believed to be a hot topic of the moment, energy security. So in the upcoming 45 minutes, we are going to talk about success stories which are currently being written and which are to be written. And we are going to talk about this with, well, I would call them 4 key players of this everyday battle about security of supply. Please join me on the stage. I'm calling Patrick Fragman, President and CEO of Westinghouse, Petro Kotin, President of Energo-Atom, Petra Lundström, Executive Vice President at Fortum, and Valentin Nikolov, Chief Executive Officer of Kozloduy NPP. Please sit down. So, before diving in our topics, I would like to kick off our debate with you, Petro Kotin, because I think that everybody in the audience would like to hear and to have an update on the situation of nuclear power plants in Ukraine. Thank you, Petro.
Okay, thank you very much, Madam Chairman, and good afternoon, ladies and gentlemen. Friends, colleagues, partners, and in Ukraine at the moment we operate 9 units of our 4 nuclear power plants. 3 of those are located on the territory controlled by Ukraine, and unfortunately still, from the very beginning of war, we have Zaporizhzhia nuclear power plant, which is occupied by Russians. And this is the biggest nuclear power plant in Europe, 6,000 megawatts, and it is not in operation since September last year. And from that time, all kind of troubles happening in there, and I would qualify any direction of operation of the plant like complete degradation of equipment, personnel status, and also safety. Any aspect of operation is damaged and actually impacted by this operation. Our requirement, and also this is part of resolution from IAEA made by 3 weeks ago, that the plant should be immediately transferred, the control on the plant should be immediately transferred back to us, legal operator of the plant, licensed operator of the plant, just to avoid further degradation of equipment and plant conditions. Otherwise, all 9 units which are located on the controlled by Ukraine territory are at full power right now, completely reloaded, Maintenance was done, and they are prepared for the winter season, and this is the basic generation in Ukraine during upcoming war winter season. Thank you.
Thank you very much, Petro. Well, we'll stay with you to talk about, because in this challenging environment, you're also preparing for the future. So I'd like to come back on what has been done in the past 2 years regarding fuel diversification, so that to ensure security of supply for Ukrainian NPP. So how have you done to overcome this dependence from Russia?
You know, we were heavily dependent from Russia before. Before actually the year 2014, when they annexed Crimea. And from that time, we actually started to understand their policy on this annexation of Crimea and then possible invasion to Ukraine, to other territories of Ukraine. And that was the time when we started diversification of the sources of supply of spare parts. And we transferred from Russia suppliers to Western suppliers and to domestic suppliers. We have in Energoatom, we have special factory which also produces a lot of spare parts which were previously supplied by Russia. And we continue to increase their production to develop technology which will supply us needed spare parts which were supplied by Russia. And the most important thing is just changing of the supplier of nuclear fuel. And this is Westinghouse and Mr. Patrick Fragman, who is presented here. We started early in 2005, and we were the first country who made this transfer from Russian supplying the fuel to the Western supplier to Westinghouse. The fuel was developed for VVR 1000. And right now, we completely cancel all the contracts with the Russians on supply of the fuel. And one of the recent achievements was supply by Westinghouse the fuel for VVR 440 reactors. And it was developed, licensed in very short term. And this fuel already installed at Rivne nuclear power plant at one of our units. VVR 440 and successfully operated.
Thank you, Petro. I'm turning to you, Patrick, because this question of fuel diversification have been very high on the agenda of Westinghouse. Can you tell us about everything you have been doing for the past 2 years regarding this diversification?
So I think, as Petro was saying, as any of those type of situations, there is a mix of planning, a mix of decisiveness, and a mix of luck. The thing is, we were starting to develop effectively the fuel for VVR 1000, and we're starting to think about VVR 40. And what happened in February last year gave us confirmation of what was written on the wall, what many people didn't necessarily want to see, which is we needed a technology that was completely independent from the Russians to help not only Ukraine, but also the 17 reactors of Soviet design which are operating in the European Union. So that's where we realized that this was something that necessarily had to be tackled as an industry. And I think that's also maybe a lesson. When you're facing a big challenge, you can't do that alone. And we went together with a certain number of utilities and we said, okay, how do we together tackle the challenge? Obviously, we had already a thinking with Ukraine, which is we had to create this program for VVR 440, where, to say it in direct words, we basically developed a fuel in less than 18 months that normally takes 5 to 7 years. And this has been done by extraordinary teamwork between all the players involved, Energoatom, Westinghouse. There was also lots of discussions with regulators and stakeholders to make sure that we could effectively do the first loading of VVR 440 fuel in Rivne in September. And since then, it's operating flawlessly. So it has been an adventure, but again, the technology topic behind is more a fundamental long-term vision. We needed to have a technology that was completely independent from Russia, And we're happy to have reached that point, and we're actually the only company that is effectively completely independent from Russian technology.
Thank you, Patrick. So Patrick mentioned teamwork together. You're part of the team, Petra, so please let us know about how it's happening in 442.
Yes, thank you. Yes, and good afternoon, everyone. Yes, this is exactly the case that we are owning and operating the Loviisa reactors in Finland, and basically they are VVR 440s. And let's say that the backdrop of this whole story is that we already some 20 years ago actually tested and licensed BNFL fuel in Loviisa. However, for various reasons, we decided to go ahead with the supply from Russia. And then in 22, it became obviously quite clear for us that we need to diversify the fuel supply for these reactors quickly. This was already the plan because we are extending the lifetimes of the reactors with 2 decades basically, and decided that we need to diversify the supply. But now then it became a very urgent matter because Loviisa stands for 10% of the electricity supply of Finland. It's 10%, so it's a big deal. And then we started to work, yes, in a very cooperative spirit, I have to confirm that, with Westinghouse and with also STUK, the safety authority, because typically licensing the new fuel would take an enormous amount of time, I mean years after years, and now we need to think smart and we need to do it very efficiently to be able to ensure to mitigate this risk of not having fuel for the reactors. And now I'm very happy to say that this work is progressing well. This is public information. We signed a contract with Westinghouse a year ago, rather exactly. And we actually also have the first test assembly without the uranium in one of the reactors already from this summer, and seeing how it mechanically basically is holding up there. And the work is progressing well. We have a very tight interaction, and I do firmly believe that this risk the risk of disturbance in the fuel supply for Loviisa is very efficiently mitigated. And the work continues, but then also to add, it would also be great. I mean, Europe, I feel really Europe needs to invest in the critical parts of the fuel supply chain and think smartly about this situation. And of course, we would like to also to have other suppliers coming in the decades to come for Loviisa.
Thank you, Petra. So, Valentin, you're also part of this success story about fuel diversification. Please give us your point of view from speaking from your role as a Chief Executive Officer of Kozloduy.
Thank you for your questions. Good afternoon, ladies and gentlemen. As the CEO of the Kozloduy MPP, I represent the nuclear power plant whose commissioning nearly 50 years ago marked the beginning of the nuclear energy in Bulgaria and in Southeast Europe. Bulgaria's energy strategy provides for the development and construction of new nuclear facilities, taking into account the long experience in the nuclear power sector, the accumulated knowledge and experience. And in view of the significant role of the nuclear energy in achieving the decarbonization goals, the process started with the decisions of the Council of Ministers of April 2012, whereby the government of the Republic of Bulgaria gave its consent in the principle for the construction of new nuclear unit at Kozloduy MPP. On May 2012, the project company Kozloduy MPP New Build was set up. The newly established company is an independent legal entity with Kozloduy MPP. The decisions of the built nuclear facilities at the Kozloduy site was made considering the availability of the necessary infrastructure and the required trained and prepared personnel. In accordance with the requirements of the Ministry of Energy and Water, an environmental impact assessment has been carried out including also the transboundary aspect. In 2019, the environmental impact assessment report came into effect after approval by the Ministry of Environmental and Water. A radio ecological monitoring program has been put in place for the processed site for Unit 7 in accordance with the provisions and decisions of the Ministry of Environmental and Water. On February 2020, Kozloduy MPP new build received an order from the Nuclear Regulatory Agency, approved Site 2 for the location of a new nuclear unit. On January 2023, this year, the Energy Committee of the National Assembly instructed the Council of Ministers of the conducted negotiation with the US government to conclude an intergovernmental agreement for the constructions of new nuclear unit at Kozloduy MPP using the AP1000 technology. On August 2023, the Council of Ministers adopted the decisions to declare the new nuclear power plant at the site approved by the Nuclear Regulatory Agency, a site of national importance and the national site. On October 2023, Memorandum of Understanding were signed between Westinghouse and the 5 key Bulgarian suppliers in support of the upcoming nuclear project based on the AP1000 technology in the Kozloduy MPP site. On October 2023, by decision of the Council of Ministers, the procedure for the constructions of Unit 7 and Kozloduy MPP was launched. For this purpose, the capital of Kozloduy MPP new build was increased by 500 million leva. The Ministry of Energy was instructed to undertake the necessary action for the construction of Unit 7 and after that Unit 8 at Kozloduy MPP site number 2. By organizing a transparent selection of constructor for the design construction and commissioning of new unit, the final contract with the select company and with the supplier for the AP1000 technology shall be drawn up the fixed price and fixed term of implementation. In addition, the Ministry of Energy shall organize negotiation with financial instruction to secure the necessary loan fund. But after invasion, Russian invasion in Ukraine, we have decision of National Assembly for the diversification of fuel, fresh fuel for the Unit 5 and Unit 6. Signed a contract with the Westinghouse for the Unit 5, and next year we implementation this fuel to Unit 5. We signed a contract with Framatome. In 2025, we implementation this fuel in Unit 6. Thank you.
Thank you very much, Valentin, for reminding us that energy security goes on 2 feet. There is diversification of fuel supply, but also building new nuclear plants. So I'd like to elaborate on this, or to let you elaborate on this point, so that we have a clear view on what's happening in the field of new nuclear power plants. Petro, so what are the plans in Ukraine?
Yeah, you know, we have a program right now approved by the Ukrainian government, and this program puts very ambiguous goal for us in terms of nuclear new design and new build. And it says that up to 2050 we are to produce 130 billions of kilowatt hours of electricity per year on our nuclear units. And right now we're producing like 45 without Zaporizhia, and with Zaporizhia before the war we produced 85. So 130 would be like 50 more of billion of kilowatt hours per year. And to fulfill these requirements, this goal from our government, we actually decided to build new units, and those units are AP1000 units. And right now we have a memorandum with our partner Westinghouse to build these units, and we started work on first 2 already at Khmelnytskaya site, and 7 more actually already on paper, and we are preparing to do that. Another point here is just to prolong the operation of existing units, and originally they were planned and designed for 30 years of operation. Right now we have already many of them above 40 years, and we are thinking about the program to increase this term of operation for 60 years, and probably then we will have a goal to move them to 80 years of long-term operation. We are starting working on that just to fulfill this goal. Another point is small modular reactors, and we have memorandums with different companies who develop this technology. One of those is also AP300 Westinghouse, and then this is our goal, and that is what we will be doing very actively after the war, actually.
Thank you, Petro. What we just heard is that there is many things we can do in order to increase nuclear energy, life extension, nuclear new builds, with large power plants, with SMRs. What part of the recipes, or maybe all of those recipes, is Fortum using?
A little bit all of them, indeed. I mentioned that the lifetime of the Loviisa reactors are going to be extended from 2730 till 50, so in more than 20 years. But then it's also a fact now, I think, precisely because of the crisis we have gone through and are in still, actually, and the emphasis on security of supply and the importance to decarbonize. In Finland and also in Sweden, obviously, the acceptance of nuclear is at an all-time high, and people are quite in favor also of going forward with new build. In Finland, we have a government program that is extremely positive and really wants to push and make new build happen. And in Fortum, of course, nuclear is in the core of our strategy. We have a nuclear power production both, as said, in Finland, but also quite a lot in Sweden. And we have quite a lot of competence in this area. So we have also then decided to look very seriously how we could go forward possibly in new build. So we started a feasibility study a year ago. It will continue for next year still. And there we are looking, some people say it's the SMR study. It's not quite the SMR study. We are looking at both large and available reactors and also at SMRs, basically, and engaging actively with all the relevant important reactor suppliers and understanding the maturity of the designs and the different features, the licensability. Also, perhaps they can trying to see the competitiveness, that's a very important question. And then in this study, we are also engaging quite actively with our customers, basically large industrial customers who are interested in nuclear electricity and possibly heat, and especially in this even weather independent profile of electricity from nuclear, because Fortum will go forward in the situation. We need to understand that there is a demand. This is associated with demand growth in this market. So we tie both these aspects together and also actively try to engage in discussions with our respective governments in Finland and also in Sweden and with the safety authorities, that what would be needed to enable a company like us to go forward in new nuclear. So there's quite a lot of activity, actually.
Thank you, Petra. So from what we hear, Patrick, is that there is, in those countries and others, a good level of adoption of AP1000, AP300. If we widen the scope, the geographical scope, what can you tell us about what you see about this global market and its eagerness for new build? And maybe also we'd like to hear from you about this micro-reactor, the eVinci, because if I'm not wrong, it made the news a few days ago.
Yes, it did. So first, before talking about the technology, I would like to say a few words on the needs, the market evolutions. And what we see now is a greater diversity of uses of nuclear energy in different forms. Some users might want, like utilities, which at scale, some electricity production, backbone, low cost of electricity. Some industrial users might want a mix of electricity and heat, for instance, with operating in a model where cost of electricity might be a little bit higher, but there will be other advantages to have versatility and later on even hydrogen production made out of the SMR. And the third type of users are indeed linked to the fact that the grids of the future are not those very large centralized grids, but more hybrid grids with some parts which are distributed generation of grid applications where you will find remote communities or mining companies in vast and remote areas which will want to have access to power, a certain power density, uninterruptible, 24/7, reliable, and rather cheap, competing with diesel generation, which in this case is the other alternative to those users. So that describes a little bit the way we looked at the evolution of our portfolio with large reactors for users who predominantly want cheap electricity at scale, reliable, and the AP1000 has a fantastic record of availability, 92% plus, and enables to reach that, and definitely the success it has internationally is demonstrating this. We have 5 units in operation, 6 more, 1 more in next year, and 6 more to come in the years to come before the end of the decade. In the middle range, the AP300, which virtually is the only SMR based on an operating plant because it's a copy-paste of the AP1000, just some components are smaller, 1 loop instead of 2 loops. Licensing will not be a risk. We already started to work on the licensing, and definitely we already foresee a lot of interest for customers who don't want to take a risk to develop the technology and who effectively want an attractive cost of the energy. And last, eVinci. eVinci is a different game in the sense that we are looking at applications 3 to 5 megawatts electrical, operation 8 to 10 years uninterrupted. Same feature as the large reactors in terms of flexibility of load. Just to give you a comparison, AP1000 like AP300 can flex plus minus 1 megawatt per second, which is extremely fast, like combined cycles typically, and that adapts in the energy systems of the future should some operators want to use those features, and should obviously the market models enable to remunerate the operators for that. So I think the message that we see before this is before the model was much more simple, the buyers' profiles was much more simple. Now we see a complete explosion of the number of potential use, potential buyers, potential technologies, and obviously that drives also the way we put our efforts on this.
Well, thank you. I'd like to go a bit further beyond, because what strikes me in what you say is that the main driver today for nuclear energy is demand, and also diversified demand, which is new. So the question I have is how to make sure that we are ready, the industry is ready at the right scale, because we are talking about scaling up all these efforts, especially if I come back to something which is going to happen next Friday in Dubai, especially if we consider the climate emergency. We all know that in Dubai at the COP28, some huge announcement will be made that we need to triple nuclear power in the upcoming decade. So how do we do that, and are you ready?
So these are 2 questions, and I think I will answer the second one through the first one. The way we approach it is the only way for us to make it is if we leverage what we have. And that was fundamentally also the story behind the way we approached the AP1000. We realized that the AP1000, we had gone through so many issues because we started construction without finishing the design. I mean, lessons learned that are basic lessons learned, that we now have a stable basis of design because we have 6 units built, 5 in operation, so we have one design. The contract we signed in Poland will be unit number 13 in operation because we will have 12 in operation in the world. And then the reference plant for Poland is Vogel 3, which is already in operation. So to go back to your point, I think we don't have time, we don't have the capabilities today in many parts of the industry to start redesigning things because that's going to be another source of schedule, cost overrun, first of a kind. The second lesson is you need a supply chain active. And that's why for us, it was strategically important to have also the SMR, which uses the same architecture as the AP1000. It's not only the fact that the licensing, frankly, will be a walk in the park, it's the fact that it's virtually the same supply chain as the one we have from the AP1000. So all the training, the competencies, the skills that you can have when you launch one program will immediately benefit the other program. The regulator itself will not have to set up 2 different teams. The NRC started to engage with us on the licensing of the AP300. It's the same team as the team which did the licensing of the AP1000. So that's another thing that we have to take into account and not underestimate is there are potential bottlenecks everywhere in the system. It's going to be a system and a mesh of decision-making which have to be perfectly aligned, like the Swiss cheese, at the right point in time to enable decisions to move through. So we try to make it as easy as possible. And last but not least, effectively making sure that we get all the learnings and the fleets. And that's a little bit the way we looked at Central and Eastern Europe. I mean, obviously, Ukraine has very large needs. 9 units is a lot. But other countries in Central and Eastern Europe have smaller needs, 1 unit or 2 units. Other countries in Europe or around the world have also not so big needs. It's the same design, same supply chain. So benefit of that fleet impact, even across geographies, same standards, is going to be extremely helpful. And you could think, for instance, that the nuclear safety regulators would have more of a nationalistic approach and say, no, we'd like our design to be slightly different and so on. In fact, wherever we go now, and we engage with many regulators, because we also help our customers on the install base, the regulators are extremely open to that type of approach. To say, standardization, perfect. It has already been approved and validated by a respectable regulator, we take it.
Thank you. I'm turning to you, Petra, because you mentioned the huge need for electricity production increase in your region, in Finland and Sweden. And we all know that the green industry is very much interested in, in settling in countries where you have a lot of electricity available. So same question about the readiness and possibly about the possible bottlenecks that Patrick referred to. What do you see as bottlenecks in your country?
Yeah, I thought about what needs to happen for the growth in nuclear to be possible exactly, and we didn't synchronize with Mr. Fragman, but the messages will be very much the same. First of all, I feel, we need to get going with new build. We need to get in the learnings. And the first, let's say in the Western world, and the first ones have been difficult and costly and painful, but very, very valuable. And then basically go along and then start to succeed better, the supply chain to be there and to learn and to learnings. It's so important. Then also, I'm also totally echoing that we need to get away from excessive modifications of the designs for various countries, maybe small countries even, and having these kind of unique reactors built and tailored. And this is not the way to go forward in nuclear, very frankly. And then also we need to build in series. I think Patrick used the word fleet. We need to build in series in order to achieve really going down on the learning curve. And in that way also we can ensure that nuclear is a competitive production form compared to the other production forms. This is very, very important. And then I think one maybe additional point, And it was super nice here at this event to see so many young people. I think we need to make nuclear exciting again. I mean, it is super exciting. It's one of the most interesting things in the world. And attract talent, super talented people, and the best competence. This will really be important for the growth that we foresee and want to achieve.
Thank you, Petra. I don't know if Petro, Valentin, you want to add something about the specific conditions in your country to have this new build happen. What about the young people? Are they attracted by working in the nuclear sector in your country?
Perhaps have a feasibility study for the Southeast Europe, and this study to 2050 this region needs 11,000 megawatt capacity for this region, because many countries close coal plants, because grow up the electricity car, and this 11,000 megawatt base electricity needs this region. In this region, countries who commissioning nuclear energy is Hungary, Bulgaria, and Romania. 11 reactors needs. And this is a big problem for the region. Of course, we need young people to study for this 11 reactors. And I think it's a good program for Bulgaria for the study for the young people. I don't know. It's a big problem for us. I think it's a big problem for many countries. But if we build and we have a strategy for the future, I think everything is okay. Thank you.
Thank you, Petro.
Yes, thank you. As I already said, we are planning a very ambitious new build in Ukraine, and this is because we will need renovation of the country, renovation of the industry after the war and after the victory in this war. And the other reason is we just need to supply electricity for our upcoming generations in Ukraine, just to provide electricity and heat to them, not leave them with very old units which are now in operation. And I just wanted to announce everybody, or to bring your attention to that Ukraine is second by the capacity of nuclear units, and there, if we do not consider Russia, of course, but after France. France is the biggest operator of nuclear power plants by installed capacity, and then goes Ukraine. We have like 15 reactors, and it is like 13,800 megawatts in Ukraine of installed capacity. And another reason is our coal plants are rather old at the moment, so we need to replacement to them. And this is where we consider this small modular reactors project, just to replace this old coal plants, and we consider all sites where right now they are located just for replacement coal plants by new small modular reactors. And this is a biggest purpose, goal, and we will do that.
Thank you, Petro, for reminding us of the fact that the other nuclear giant in Europe is Ukraine. So I'm happy to open the floor now for questions. We have 10 minutes, so please briefly introduce yourself and brief questions so that our speakers can answer you.
Good afternoon. My name is Dalibor Mateju. I am from the Czech Republic. I am the nuclear veteran. We are in cooperation with also Ukrainian nuclear veterans. And I would like to ask all speakers, what is their opinion concerning of the backside of the fuel cycle, which has to be solved in the enormous grow-up of the nuclear reactors, And also, what is your opinion concerning of the safety of nuclear power plants during the terroristic attacks or some invasions like the Russian one? Thank you, for answer.
Thank you. Who wants to answer? Fuel cycle safety. The back end of the fuel cycle, it was a question. Sorry, the acoustic is a bit difficult. Who wants to address?
Maybe regarding the back end of the fuel cycle, I think this question that it needs to it needs to be resolved what to do with the spent fuel it's really important, and it's also a huge question related to the acceptance of nuclear power. That is there something that cannot be resolved? And from my own perspective, of course, in Finland we are going for the final disposal of the spent fuel, and we are constructing the repository, and in fact Posiva will start to put down the spent fuel there in only a couple of years, and Sweden has the same basic technological solution and coming a little bit behind. But and there I know there are different possibilities in different countries for very sure, but this we need to move forward. We need to have the solutions. We need to show that this is not the kind of unsolvable problem.
Maybe in complement to what you just mentioned, Petra, I think the nuclear industry, the next wave of big topic will be around waste management. And it's not so much a technology question. As Petra said, a certain number of countries, take Finland, take Sweden, take Switzerland, show the way. So it's more a matter of political willingness. And if you take a region like Europe, for instance, there are 27 countries in the European Union. It's hard to believe that there will be 27 independent solutions. So there needs to be a little bit of political courage to tackle the topic also at regional level and to find solutions that make sense at regional level. To your second question, I would start by saying that there is no human infrastructure which is designed to resist a war. None. As we've seen in Ukraine, dams can also be damaged in a war. What we can do, we can engineer against a certain number of scenarios. And for instance, the AP1000 has been engineered with a double containment. As you may know, the NRC has asked us, I think in 2011, to add a second containment on the AP1000 to foresee a case of a fall of a missile. In that case, it was an aircraft, a commercial aircraft. But at the end of the day, again, no human infrastructure can be fully bulletproof against a war.
Thank you. We have time for a second and last question. Yes, sir. If you can speak loud, because it's sometimes difficult to hear well from here.
Hello, good afternoon. My name is Hani Labaki. I'm a project director working in Westinghouse. And my question is to you, Petra. You mentioned earlier at many occasions the scarcity and the need of energy in Sweden and Finland. Is there any plan in the short or midterm to relaunch the Hanhikivi power plant nuclear project that was terminated almost a couple of years ago? And is the AP1000 a good option for you? Thank you.
Thank you for your question. And yes, you are right that the projections regarding the electricity demand growth are rather steep upwards in both in Finland and in Sweden, and it's based on the green transition, and it's based on the hydrogen economy requiring lots of electricity and green steel manufacturing especially. So that's where it comes from. And new nuclear would fulfill it very well. It would fit in very well. As to your question regarding Hanhikivi and how that would be revived, it's not a Fortum project or site, obviously, but commenting generally that it's now kind of part of a significant dispute. And the site, which is a licensed nuclear site, which is something very valuable, obviously, it's in the midst of a dispute. And it's very hard for me to speculate and see that how this might go forward. But I'm all for really going for new nuclear, given that we start to see that this demand growth and these large industrial investments are coming to the Nordic countries. They will need a lot of electricity. It's a little bit of a chicken and an egg, but this is certainly something very interesting that we are following closely and would be the basis for new nuclear.
Thank you, Petra. Well, it's time for us to conclude, and I would like to share with you my 2 takeaways from this session. First, we often hear that nuclear is not compatible with emergency, with being fast. Well, I think that in the first part of this session regarding fuel diversification, it has been proved that accelerating and nuclear are not incompatible. Second takeaway, well, I will quote you, Patrick, because I think you gave us some ingredients of the recipe for this nuclear success we need for the climate and for competitiveness. The 3 ingredients are, if I noted them well, planning, success, and decisiveness. And I will leave you with this final word. And thank you very much to our panelists.